When you type a question into ChatGPT, something genuinely strange happens in the next 2 seconds. It doesn't understand you. It doesn't look anything up. And once you see what it's really doing, every weird thing AI does, the hallucinations, the math errors, the eerie brilliance, finally makes sense. To see it, you have to start with something the AI never actually sees: words. Because to a language model, this sentence isn't a sentence. It's not even letters. It's a string of numbered fragments called tokens. A token is a chunk of text, sometimes a whole word, sometimes a piece. Unbelievable might split into unbelievable. ChatGPT becomes chat and GPT. Each chunk gets a number. The entire English language compresses into about 100,000 of them. So the first thing the model does is convert your sentence into a list of those numbers, which means we still haven't gotten anywhere near thinking. Those numbers have to mean something. So how does a number mean a word? The model owns a giant lookup table. Every token points to a list of numbers, about 12,000 of them for modern frontier models. That list is called an embedding, and you can think of it as coordinates in a 12,000 dimensional meaning space. Here's the wild part. In that space, similar ideas live close together. King lands near queen. Paris lands near France. You can literally do math on meanings. Take king, subtract man, add woman, and you land near queen. So your sentence is now a cloud of points in meaning space. The model has a geometry of meaning, not a dictionary, but points just sit there. To do anything useful, they have to talk to each other. Imagine every word in your question looking up and asking every other word, "Hey, are you relevant to me?" That mechanism is called attention, and it's the single idea that made modern AI possible. It came from a 2017 Google paper with one of the most arrogant titles in research history: "Attention is all you need." Turned out they were right. Attention lets tokens reweight each other based on context. The word bank looks at river and shifts its meaning. The word it reaches back, finds the dog and grabs onto it. Stack this thousands of times, across dozens of layers, and the model builds up an extremely rich, context-sensitive picture of what your sentence is actually about. By the top of the stack, every token is humming with information borrowed from every other token. But notice, it still hasn't answered anything. It's only processed your input. So what is it actually trying to do? This is where almost every explanation gets it wrong. An LLM has exactly one job: not answer, not understand, predict the next token. That's it. After processing your prompt, it outputs a probability for every one of those 100,000 tokens in its vocabulary. It picks one. Then it appends that token to your prompt and does the whole thing again. To produce a paragraph, it runs this entire machine hundreds of times in a row, one token at a time. Yes, the model that just explained quantum mechanics to you was, technically, playing the world's most expensive game of autocomplete, which sounds dumb. So how does that ever produce anything intelligent? The answer is in how it learned. Take roughly the entire internet: books, papers, Wikipedia, forums, Stack Overflow, code repositories, trillions of words. Now hide the next word and force the model to guess it. When it's wrong, nudge its billions of internal numbers, its weights, a tiny bit in the direction that would have made it right. Then do that over and over, for months, on tens of thousands of GPUs, until the model is shockingly good at the game. Frontier models have hundreds of billions of these weights, trained on trillions of tokens. The training run alone costs tens of millions of dollars, and out the other end comes something that, just by getting really good at guessing the next token, has to encode grammar, facts, reasoning patterns, code conventions, and the rhythm of human conversation. Not because anyone taught it those things, because they all fall out of getting really, really good at the guessing game. Which means, and this is the part nobody tells you up front, the model never has a goal. It never plans a sentence. It is always only asking, given everything before, what's the most likely next token? So why does it ever get things weirdly, hilariously wrong? Same reason it gets things right: tokens. Ask GPT how many R's are in the word strawberry, and for years it has confidently said 2. Not because it can't count, because it doesn't see letters. It sees the token straw and the token berry. The letters inside are invisible to it. It's like asking you how many vertical pixels are in your reflection. You can answer, but you have to count something you don't natively perceive. Same with math. Why can frontier models pass the bar exam but flunk a 12-digit multiplication? Because each digit is its own token, and the model is pattern matching what digits usually follow other digits, not running an algorithm. It's faking arithmetic from memory. Once you see this, you can predict where AI will be brilliant and where it'll fall on its face. But hang on. The new reasoning models think step by step. They show their work. Surely that's actual thinking. It's called chain of thought, introduced in a 2022 paper from Google researchers. They found that simply asking a model to think step by step before answering massively improved its scores on math and logic problems. The trick is generating those intermediate tokens gives the model more space to compute. Each step's tokens become inputs to the next prediction. So when a reasoning model spells out a chain of logic, it's not retrieving a hidden thought process. It's literally constructing one in front of you, token by token, and using each token as a foothold for the next. Useful, but it's still just next token prediction wearing a hat, which leaves the deepest question. Is there a mind in there at all? For years, the honest answer was, we don't know, because the inside of a neural network looks like noise. Then in 2024, somebody actually opened the hood. Anthropic, the company behind Claude, released research called Scaling Monosemanticity. They didn't ask the model what it was thinking. They probed its internal numbers directly, hunting for recognizable concepts inside the network. They found millions of them. A feature that lit up for the Golden Gate Bridge, across languages, across image descriptions, across the phrase famous Orange Bridge in California. A feature for code with security vulnerabilities. A feature for sycophantic praise. They turned the Golden Gate feature up to 11, and the model started insisting that it was the Golden Gate Bridge. So yes, there are recognizable concepts in there. But here's the punchline. Those concepts only exist because predicting the next token well enough required them. The understanding is downstream of the autocomplete. The mind, such as it is, grew sideways out of a guessing game, which brings us back to the original question. Here's the honest answer in one sentence. An AI model is a giant pattern completion machine that, by predicting the next chunk of text well enough on the entire internet, was forced to learn fragments of grammar, reasoning, and world knowledge. But it has no goal, no inner narrator, and no concept of true. It's not understanding. It's not a database. It's the world's most overtrained intuition. It tells you what feels like the next right thing to say, which is why it can write a beautiful sonnet about your dog and then confidently invent a court case that doesn't exist. Both are doing the same thing, guessing the next likely token. So next time it amazes you, remember there's no thinking. There's just a very, very large guess. And once you stop expecting it to understand, you start using it for what it's actually good at. Shape, style, and pattern, not facts, not arithmetic, not certainty. Which opens a much darker question. If the model is only ever guessing the next token, it has no built-in concept of being wrong, confident, fluent, wrong. Those aren't a glitch, they're baked into the math. Why AI hallucinates and why it probably can't be fully fixed, that's the one that actually matters, and it's right here. I'll see you in it.